Good morning. We were discussing the operators, uh, the different Java operators, which can be divided into groups such as arithmetic, bitwise, relational, and logical. We tried to finish arithmetic and bitwise. Now we'll see some of the programs associated with this arithmetic and bitwise, and also we'll take up, if it's possible, the relational type of operators today. And then we'll try to see how we can execute some of the programs associated with relational operators also. So if we go to the book over here, we have here a program written for basic arithmetic operators. So you can see that we have written here, same thing, basic maths. That will be the name of the file also, because that is having a main over here. Class name and the file name should be same. If you have what you call multiple classes within a single file, one of the what you call classes should have the same file name. So further to that, because you have here a main, within the main we have here a system.out.println integer arithmetic, so it will print it integer arithmetic. Now it'll just calculate a is equal to 1 plus 1, that is 2. Then b is equal to 2 into 3, that is 6. C is equal to 6 by 4 because it's integer. 6 by 4 is 1.5 because it is integer. It will give a value 1. And then d is equal to c minus a, that is 1 minus 2. 1 minus 2 will be minus 1, and e will be equal to minus of d minus 1. Minus of minus 1 will give us the value which is plus 1. So 2 for A, 6 for B, for C1, and for D minus 1, and for E it is again 1. So that's what it is going to print over here for this, right? It is going to print for this value. Similarly, now we have the next part, which is floating point arithmetic. For floating point arithmetic, we will get a value here 1 plus 1, 2. 2 into 3 will be 6. So it will just give for double. It will give you 2.0. 2.0 into 3 will give you 6.0. 6.0 by 4 will give 1.5. Then here, 1.5 minus 2 will give us minus 0.5. And then this will give us, minus of minus 0.5 will give us the point value, which is plus 0.5. I hope I'm making very clear. So hence, it will print over here the values which are, 2 here, 2.0 here, 6.0 here, 1.5 over here, 0.5 with a minus sign over here, plus 0.5 over here, okay, plus 0.5 over here. So those are the values it's going to print, and that's what it is showing here. Okay, 2, 6, 1, minus 1, 1, because it is integer, and then you have a floating point values, and hence it is showing that value 1.5 minus 0.5, 1.5. So how do you execute it in the web interface? Now I might have written it in Codiva. I just copied the whatever program is written in the Codiva interface. So it is Codiva. You can put in Google search Codiva and then enter. Might be I don't remember one of them. You need to register, but registration is very simple. In the others, there's no need. Like for example, JDoodle, you don't need any registration at all. Okay, you need to put JDoodle or Codiva or Rex Tester or whatever might be Open GDB. So I'll just send in your WhatsApp group the list of interfaces which we can web interfaces which we can use for running the Java programs. Okay, now let us go to this Codiva. So we have written this program over here. So if you try to run this, it's going to give the result. Okay, A is equal to 2, B is equal to 6, C is equal to 1, D is equal to minus 1, E is equal to 1, and the DA is 2.0, as I said, 6.0 dB, 1.5 DC because it is 6 by 4. Then it is 1.5 minus 2, 1.5 minus 2.0, that will give minus 0.5. D is minus of this dt, that will give us 0.5. Okay, so this is the result which we are going to get. right? So that's what we have. Let's go back to our program set. So now next we have the modulus operator. Modulus operator, if you see again how we have declared x as an integer and assigned a value which is 42. This is known as declaration, and this is known as assignment, because we have equal to. Then similarly, y is declared as double, and it is assigned a value which is 42.25, right? So now in the system.out.println, we are trying to write x mod 10 equal to within the quotes, so it will print this string. This is just a string, and because it is within quotes, it will print x mod 10 equal to. Okay, it will print x mod 10 equal to as it is, because it is within the double quotes. Then later we have the delimiter plus, and then we have put here x modulus 10, so that will give us 42 modulus 10. So it will divide 42 by 10, and the remainder will be naturally what will be the remainder? Can somebody tell? Can somebody tell what will be the remainder? Am I with you, or are you with me? So what is the value? Modulus of 42 divided by 10. 42 divided by 10, right? So modulus just means it will give you a remainder. 42 by 10 will give me 4 as the quotient, and 2 as the remainder. Yes, 2 as the remainder, right? So 2 will be the remainder. Next, we have declared y as double. So y percentile 10, that will give us 42.25 divided by 10, and the remainder now will be 2.25. So same thing will be printed over here. So 2 and x mod 10 is equal to 2. This string it will print, and the value of this it will print. This string it will print, and then the value of this. So y mod 10 equal to 2.25. So that will again try to run it over here. So that I have written in the, if I'm right, I have written it in the, yes, I have written it over here. So I have written it in the what you call JDoodle, what you call web interface for running the Java program. So in this, I have tried to write, and then we'll just see. I'll just expand it back. So once I execute this, then I'll get the result over here. So 2 and 2.25. 2 and 2.25. Okay. Y is 4 and 2. Okay, might be quotient, and you're writing quotient and the remainder. Fine, no problem. Okay. Okay. So we are not printing quotient, but if you want to print quotient, then you'll have to write divide by what you call 2 rather than percentile 2. So say if you write here about this system.out.println x divided by 10 is equal to, within quotes, plus x, again the symbol divided by what you call then 10, that is x forward slash 10 will give us the value equal to 4 over there. Okay, that will be the straight division. Okay. Then we can come to the arithmetic compound assignment operators. So compound means we have here a equal to a plus 4, that will be equivalent to a plus equal to 4. So a plus equal to 4 is equal to a is equal to a plus 4. Similarly, a modulus equal to 2 is equal to a modulus 2. Okay, that will be the value it will be assigned. Right. So what we have is, var op equal to expression is equivalent to var equal to var op expression. Okay. So for that, we again have an example here, which is op equals. public static void main, and this is the code which we have written. So let us go through the code over here. So we have declared a is equal to 1, b is equal to 2, c is equal to 3, and all these are of the type integer. Okay, of the type integer. So now we have written here a plus equal to 5. What will be the value of a here now? Can somebody write a plus equal to 5? So a plus equal to 5 is nothing but a is equal to a plus 5. So a is 1. So how much will get a? A will be naturally 6. Okay, it's visible. Okay, so it's visible. That's why one can tell it very clearly. Right. So then b star equal to 4 will give you b is equal to b star 4. Okay, that is 2 multiplied by 4 will give us the value which is 8. Okay. 2 multiplied by 4 will give us the value which is 8. Then c is c plus equal to a into b. Okay, c plus equal to a into b, that is c is equal to c plus a into b, and that will give us c is 3, a is the value which is 6, and what you call b is 8, that will give us the value 48. So 48 plus the value 3 is might be we will get the value which is 51 at this point. Okay, 51. So immediately after this statement, if you print the value of c, it's going to give you the value which is 51. Now after that, you're writing here c is c percentile equal to 6. That will give us the value c is equal to c percentile 6. 51 percentile 6, 51 modulus 6 will give us again the remainder c equal to 3, and that's what is printed. So let us see this, and also we'll try to introduce the another similar statement over here, that is system.out.println c equal to plus c after this, and see how much we'll get the value of c. Naturally it should be 50 what you call 1. Okay, it should be 51. So I don't know whether I have written this for here. No, this is hello world. Whether I have put it in Dexter? No. Godiva? No. Okay, let me cut and put it there in the what you call interface of the JDoodle. Then I think might be that will be, we can execute it from there. Okay, so I'll cut this from here, copy, then go to the so to say over here, and oh, it is not typing. First I'll delete this, then so then I'll paste this. Okay, so I pasted this. Now having pasted this, I'll try to run this code. Okay, so let me execute this code. So it's giving the output. Okay, 683, whatever we expected. Now equally well, I'll just try to what you call, take it out from here, this particular statement. Okay, copy, then I'll write it here. Okay, so you can write it in the next line, or you can. So after this, that means first it will print c is equal to the value 51, and then it will come back to a, b, and c if I execute it now. Okay, so see, it is printing the value 51 first, and then a is equal to 6, then b is equal to a, and then c is equal to 3. Okay, so that's the way it is going to do that. You can print at whichever point you want. Might be after immediately after this A, you can print A, or immediately after B, you can print B. Immediately after this C, it will print this C, and then after this, again, you can print C if you want. Okay, so that's the way we can, run it in one of those interfaces, right? So this is about the compound assignment. Then we have incrementation. So incrementation is x equal to x plus 1 is nothing but x plus plus. Similarly, x equal to x minus 1 is nothing but x minus minus. We also use minus minus x. Also, pre-incrementation and post-incrementation is what we have said. So how it is different if we try to write the, this is the pre-incrementation and this is the post-incrementation. So what do we do here? X is equal to 42. Then X is incremented by 1 over here and then assigned to the value of Y. So X itself becomes, 43, and then it will assign to the value Y 43. So that means after this statement, if I write here system.out.println x comma Y, X will be 43 and Y also will be 43. Whereas if I go to this statement over here, right? This is post incrementation. So what it does is what you call the value of x is first assigned to y, so y becomes 42, and then x is incremented, it becomes 43. So in this case, x is 43 and y is 42. If I print after this statement, system.out.println a value of x and value of y, that is x comma y, if you try to put. Okay, so that's how we can do it. So there's an example over here which is written. So let us see that example for demonstration purpose and then try to execute. So here we have int a equal to 1, int b equal to 2. So that is declaration as well as assignment. Then only declaration for C and D. Then C is equal to plus plus B. So that means B will be incremented by 1. That means B becomes 3. C is assigned the value 3 by this. This is pre-incrementation. Now this is post-incrementation. That means A is assigned, the value of A is assigned to D. That means D becomes 1. Then A is incremented. That means A becomes 2. Okay. So whereas in this statement, both C and B will be the value 3. In this statement, the value of D will be 1 and A will be the value 2. And that's what we have over here. And, that is the result which we will get: A equal to 2, B equal to 3, C is equal to 4, and D is equal to 1, right? So the same result we should get if we try to execute this, code. So I'll just again, copy it from here, go to the, code in this. Delete this first. Yes. So we executed it. Yes. A equal to 2, B equal to 3, C equal to 4, and D is equal to 1. Right? This is how we can get it. So now what is important is here that, in Python, indentation is very much important, which I think Professor Arif might have already told you. Whereas in Java, we don't bother much about indentation, only that it should be within the block. The block is basically within the braces, right? Within the braces. Braces is the flower bracket. So a block is supposed to be within the flower bracket. So whatever we put in the flower bracket, that is sufficient. Where you write, whether you write in the same line 2 statements, 1 statement, 3 statement, shift it a little and write, that doesn't matter. For each statement end, you need to have a semicolon. Okay, each statement end will have a semicolon. Okay, Now let us go for the next one. Bitwise operators, right? So in the bitwise operator, we have seen a lot of bitwise operators, and then try to see how we can try to find using the what you call example. So bitwise not, bitwise and, not just means inversion of each of the bits. Okay, and or correspondingly, or is a bar and is an ampersand symbol, which we generally call it as or itself. Okay, and itself. And then we have the bitwise XOR, which is the hat symbol. XOR we know, in the DCLD we already studied it. Okay, so now we can what you call here he has just written a string which just gives you what it means is that by writing this, what we are trying to do is binary of 0 is this value, binary of 1 index 1 will be 0001, 2 is this, binary of 3 is this, binary of 4 is this, similarly binary of 15 is this. So we have taken from 0 to 15 the binary value. Okay, and the binary is of the string type. Okay, binary 0 is this string, binary 1 is this string, and so on. Okay, so we're just trying to write that. Okay, so we will try to so to say go to the next session also. So let me take this, a equal to 3, int b equal to 6, int c is equal to a divided by b, int d is equal to a ampersand b. So, sorry, it's not divided, it is rather or, okay, a or b. So 3 and 6, the value of 3 is naturally, the value which is, you can try to write it in the bit format, and that will give you, naturally the value. If it is 4-bit, it will give you 0011. But however, it will be, because it is an integer, it will be in a 32-bit format. We are just writing here only the what you call so to say the value which is 4-bit only. Okay, so 6 in 4-bit value will be 0111. If you take the OR of that, so naturally it will give you 0111 value, and that will be the value 7. C will become 7 here. D will become and of these two, that will be only a 1 will be here, that will give us the value 2. Okay, 1 will be only for this bit will give you 0, this bit also will give you 0, this bit will also give you 0, and that is what is AND. AND means both should be ones for the output to be 1, or means if one of the two is 1, then the output is 1. Then you have exclusive OR. Exclusive OR will be for this and for this. It will be 1 for the 1 1, and for the 0 0 it will be 0 0. So that will give us the value which is 5. E will be the value 5. Then F will be we need to take the what we call OR of the A, so to say, not A is inversion of A. Inversion of A is 1 1 0 0, and then that is ANDed with B. Okay, ANDed with B. 1 1 0 0 is ANDed with B, will give us the value 4 0 1 0 0, and 0 1 0 0 is to be added with again A ANDed with inversion of B. Inversion of B will give us the value here 1 0 0 1, and that will give you the AND will be just 1, and that 1 that is 0 0 0 1 for this, and for this we will get the value. How much did we get? Inversion of 1 is 1 1 0 1, and that is ANDed with this, so we'll get 0 0 0 1 and 0 0, and this will be 0 0 0 1. So if you take the OR of that, it will again become 0 1 0 1. So F will also become 5. Okay, so equally well, 5 just means, it depends upon how you write. You're trying to use the what you call string over here, and that will print that value. Then int G is equal to inversion of A ANDed with 0x0f. 0x0f is basically the value which will be 15, rather 0000111. 0000 f is 1111. Okay, so you AND that value with a, so whatever is the inversion of a, that is 1100 is going to come out, and that will be the value which will be printed. So 1100 will be the value which will be printed, because we are using the what you call correspondingly the values over here, right? So if you try to where did we go? Mhm. Yes, we were in this. So I'll just copy this. First, let me take the attendance. Okay. So we'll go back to the what you call interface here. Where it has not taken. Copy. Paste. Okay. So it has pasted now. So let me execute it. Okay. So it's going to give all that values, right? Right. So it's going to give you all that values accordingly, right? Whatever is the right value, which we will get it correspondingly. So a is nothing but 0011, and b is nothing but 000110. Then a or b is a 0111, and a ampersand. So that will be the what you call and 0010, or here and here, exclusive or over here. Then we have set this 0100 and 0001, and that will be odd, and hence we'll get 0101, and then the inversion of a will give you 1101, which is the inversion of this. Okay, so might be f is also there, which I don't know why it is not. F is okay. F is directly this value. Fine, fine. So that is what we can print, right? So going for the next, program, let us see what we can do. So that is, shifting, left shift, right shift, and all those things. Right. So here, if you see, we have written byte A is equal to 64, and B we have not assigned any value. Only declared is a byte. A is a byte value, B is also a byte value, A is 64. But automatically it will be converted into integer type. Int I, again, we are not assigning anything to it. Then let us see what we are doing later. I is equal to A. We are shifting it twice to the left hand side, that will be multiplying by 4, that will give us 256. So the value of I will be 256. Byte B will be, byte A shifted by 2 bits, or you can put I value itself over here. Either way, that will give you a byte of 256 will definitely be equal to 0. So A will give us the value 256, B will give us the value 0. Okay, so original value of A is, what you call 64, and then I is the value which is 256, and B is the value which is 0. So you can, cut and write that, code into the JDoodle, or might be in Codiva, and then try to execute it. Okay, so we'll relog in once we finish with this what you call session, for another 10 to 15 minutes. Okay, so please rejoin for the because we are not able to cover much syllabus, or otherwise we need to take might be in the afternoons 1 hour. Okay, so we can go back to the Codiva, or let me go to Codiva.